It's time to export the knowledge. So in this episode we're going to be talking about unit vectors, but this time we're going to apply it a little bit more generally. So we already know about the I vector and the j vector and the k vector, but what if I wanted to make my own unit vector? Something with a magnitude of 1 but has a certain direction. So I can actually do that. I can take any vector that I want. Let's say it's 3i plus 4j. So if that's my vector there, I can work out what its magnitude is. So the magnitude of a vector is going to equal 3 squared, which is 9, plus 4 squared, which is 16, and square root it. So 9 plus 16 is 25, so I'm left with 5. What I can do now is that I can divide my a vector by 5, and what I'll get is something with a magnitude of 1. So let's do that. Let's divide a vector divided by 5. So that's going to be 3 over 5 I plus 4 over 5 j. So now if I go to calculate the magnitude of this vector, what's it going to be? So 3 squared is 9 over 25 plus 4 squared, 16 over 25. Add them together, that's 25 over 25. The square root of 25 over 25 is just 1. So the magnitude is 1. So we have a special notation for this. We say that this is equal to the unit A vector. So this little arrow thing on top is just what we call a hat. And what that means is that it is a unit vector. Now, we don't necessarily need to put a hat on the I and j vectors, but we can if we really wanted to. We can say I and j are unit vectors like that. Not necessary though. It is perfectly fine to just do this. So, can we come up with some sort of general formula for a unit vector? Of course we can. So, a hat is going to equal to the a vector divided by its magnitude. So the last thing that I want to do in this video is do an application question. So we're given AB and we're given OC, and it says point D is 10 units away from C, and CD is in the same direction as AB. And it says, what is CD? So this is where unit vectors will come in handy. So I want to keep the direction but change the magnitude. So I can find whatever AB magnitude. So it's going to be square root of 20 squared plus 15 squared. You could also say it's negative 15 squared, but doesn't matter in the end. So this will be 400 and this will be 225. We add those together, we get root 625, which equals 25. So now that we have that, we can divide our AB vector by 25 to get AB hat. So 20 over 25, that's 4/5 I minus 15 over 25, 3/5 j. And now we just need to times this by 10, and that'll be CD. So CD is equal to 10 lots of AB unit vector. So that's going to equal 40 over 5, which is 8i, minus 30 over 5, which is 6j. quite a nice result. So now that we have CD, how about we find out what the coordinates of D is? So given the information, how can we find the coordinates of D? This is what's called the position vector. We start at O and we end at D. And if we do this, we can find the coordinates of D. And it's very, very simple. So all we have to do is find OD. Well, I know what OC is and I know what CD is, so we can find D very easily. We just add OC to CD. So 50I plus 25J plus 8I minus 6J. So we'll add these together, so that'll be 58I, and 25 minus 6, that'll be 19J. And because we're starting at the origin, we can put this into a coordinate. So D's coordinates is going to be 58X and 19Y. So that's all I have for this video. If you have a question, feel free to contact me on social media or leave a comment down below. I will see you in the next video.